So starting the discussion with the MCQs pop quiz. This was the last week MCQs pop quiz 18. If you have a question, you can mention in any question you have a doubt. Question number one. In question number one, a car of a mass 1100 kilogram is traveling at a constant speed of 15 meter per second up a slope at inclined at 10 degrees to the horizontal. The combined frictional force acting on the car are directed down the slope and are approximately equals to W by 5. So there's a frictional force is there. This frictional force is equivalent to what? This is W by 5. We need the useful power of the car engine. So what is the other force act when object is on inclined surface? Its weight is acting downward. But the weight will have the two components. When we resolve the weight into the component, like this is W. So we take an axis along the inclined surface. So this angle will be theta or 10 degrees. So the component which is with an angle, so this component will be equals to W cosine 10 degrees. And the component which is against the angle, that is equals to W sine 10 degrees. As we need the power, there are different formulas of the power. Power is energy divided by time or rate of work done. Or there's also another formula. If we know the speed, the power is force multiplied by speed. So if the car is moving at a constant speed, so there will be no resultant force. But how much force it need to overcome the frictional force, the total, and so the frictional force is W by 5, and the component of the weight which is also opposing the motion on the inclined surface is W sine 10 degrees. So what is the total force to move this car at a constant speed on the inclined surface? That is equals to W by 5, the frictional force, plus the component of the weight which is opposing the motion, that is W sine 10. So the total resultant force will be, resultant will be zero because it's moving at a constant speed, but the forward force should balance with the force opposing the motion. That's why the force should be W by 5 plus W sine 10. And then the speed is given to us as 15. So we just substitute these values. So this force will be what? It will be W by 5. W by 5 weight is mass into gravity. So 1100. So this will be 1100 times 9.8 divided by 5 plus this will be 1100 times 9.8 into sine 10. When you simplify this, this will give us the force which you need to move this car at a constant speed of 15. So that constant speed of 15 multiplied by this force, what's the answer for this force which is needed to maintain a constant speed? 1100 times 9.8 divided by 5 plus 1100 into 9.8 sine 10 degrees. 2349. So 2349 and 2349 times 15. 2349 multiplied by 15. Check this calculation here. I feel about the resultant. No, it's not. Check this calculation here about the resultant force. I think some calculation mistake you did. When you're finding this resultant, when you're finding a force, this is equals to W by 5, the frictional force, and the component which is against, that is W sine 10. So what you have to do, W by 5 plus W sine 10 degrees. Add them. So when we work out, this will be, because we can, this will be 60.4 kilowatt, 60.4 kilowatts, so C will be the right answer. So what we did is we worked out the force which is needed to move at a constant speed. that will be equals to the resistive force because the car is moving at a constant speed. So we have that force and we know the constant speed. So when we multiply, that will give us the power which is generated by the engine. Question 2, any doubt? Question 3, any doubt? In question 3, a bead is released from a rest at point P and it slides along the wire as shown. The track loops around and forms a vertical circle with a diameter of 40 centimeter. At point Q, the bead has a speed of 1.4 meters per second. The air resistance and the friction of the wire is negligible. What is the height h from which the bead is released? So this is about the conservation of energy, which form of energy it will have when it is released, and it is released from rest. So the only form of energy it will have a gravitational potential energy. But when it move around, it's moving here with a speed of 1.4 and it is at a certain height above the level. So it means which form of energy it will have? It will have a gravitational potential because of the height and it will have the kinetic energy because it is moving. And there is no loss of energy because the air resistance and the friction is neglected. So we can say that the original gravitational potential energy, the GPE, the first gravitational potential energy, is equals to the gravitational potential energy plus the kinetic energy at this point. So if we say, let's say it was having 100 joules of gravitational potential energy, so maybe 60 joules of gravitational here and 40 will be the kinetic. So we are using the conservation of energy. The gravitational potential energy is given by a formula mgh. This height, we call it, let's say h1, we are saying this as h1. The second gravitational potential energy is mgh as well, but this height, example, we are calling that as h2, plus the kinetic energy, which will be equals to half mv square. So when we simplify this, m is common, so m will cancel out. So what we are left with, gh1 is equals to gh2 plus half v square. Now we just have to simplify substituting the values. Or if, because I need h1, like I need this height. So this gravity is multiplied, other side it will be divided. So when it is divided, this h1, the height will be equals to h2 because g divided by g plus it will be v square over 2g. Because what we did, this g which is multiplied here, we divided both sides. So h1 is equals to h2 v square over 2g. You can first substitute the values and then solve the equation, or you can just rearrange the variables and at the last substitute the values, you will get the same result. So we need the h1, which we called h. The second height is 40 centimeter. It should be in meters, so 0.4 plus v square, which is 1.4 square divided by 2 into 9.8. So h is equals to 0.4. 1.4 square divided by 19.6 because 2 into 9.8. So 1.4 square is 0.19 and so we'll get 0.1 here. So 0.5 plus 0.1, what was the total height from which it is released? It is released from a height of 0.5 meter. So C should be the right answer for this. So you use just the conservation of energy. The initial is was the gravitational potential, but at point Q, so at point P, it was only gravitational, but at point Q, it has a gravitational as well as the kinetic energies. Is it clear, this one? Question 4, any doubt? Question 5. Question 4. Okay. A small diesel engine uses a volume of 1.5 exponent 4 centimeter cube for a fuel per hour. So this is a volume is used, like this is volume per time, to produce a useful power output of 40 kilowatt. It may be assumed that the 34 kilojoule of energy is transferred to the engine when it is used 1 cm cube of the fuel. So when 1 cm cube of a fuel is used, it will transfer this much energy. What is the rate of a transfer energy from the engine of energy that is wasted? So first what we have to do, we have to work out the total input power because this is a useful power. So the total input power is what? The total input power is the useful power plus the wasted power. So if I need the wasted power, the total input power minus the useful power, I'll know how much power is wasted. So the power which is useful is given to us. It's 40 kilowatt. So that is known. We need the total input power. How much power is being input or given? So 34 kilojoules of energy is transferred when it use 1 cm cube. So when it is using 1 cm cube, it used 34 kilojoules of energy, 34,000 uh, joules you can say, or 34 kilojoules. So if it is having 1.5 into 10 to power 4 cm cube of the fuel, like the volume is there, how much energy will be input? X cross multiply. So when we multiply, we'll know how much total energy input will be there. So 3.34 exponent 3 multiplied by 1.5 exponent 4. That will give us 510,000 joules. So 510,000 joules is the total energy given to the engine. But how much per hour? Like this is 1 hour. But if we need the power, how much power is given to the engine? The power is energy divided by time. So energy which is given to the engine is 510,000. And how much time? Because it's an hour. So how many seconds are there? 1 hour will have 3,600 seconds, like 60 multiplied by 60. That will give us how much input power is there. How much power is given to the engine, which is 141.67. Okay, 141 into 10 to the power 3 joules. Sorry, watt, because it is a power. So 141 exponent 3 watt is there. It is numbers are there 141.6. So I can say 141 kilowatt is the input power. This is a power which we give. So 141 is the input power. The useful power which is provided was 40. The wasted we don't know, unknown. So if we move other side, it will be like 101 kilowatt of energy is being wasted. So 101 kilowatt, so it matches with option A. So first what we did, we work out how much total energy is given to the engine and then how much total power is there given to the engine. And if we subtract the input power minus the useful one, we'll know how much power is wasted from the engine. Is it clear? Question 4. Question 5, any doubt? Question 5. Question 6, any doubt? Question 6. Question 7, any doubt? Any doubt in 7? Question 7. A mass M is on the top of a platform that is supported by a gas in a cylinder of a cross-sectional area of A as shown. The platform has a negligible mass and can move up and down freely. The gas is heated and it expands so that the mass is raised through a height. The atmospheric pressure is P. What is the ratio of the gain in a gravitational potential energy and the work done by the gas? So the gain in the gravitational potential energy means the change in height. So the gain in gravitational potential energy will be mgh. But what about the work done? Work done by the gas. Two things happen, that the gas did a work done to lift this object as well. That is one thing, because the mass m is placed. So gas did a work done to lift this object. And another thing, the gas did a work done to raise this piston to a certain level. Like changing the level of the piston, that is work done. Additional lifting this mass also, because it has to apply force and move this mass to a certain distance. So what is the total work done here by the gas? One is to raise the piston up, one is to move the mass. Work done is a product of force and distance. So to push the gas, one is to push the gas outward, one is to push the mass upward. So the total work done is to push the gas or expand the gas plus the mass, move the mass. Work done is a product of force and distance. You can write in any order, like you can write mass first and gas after. So work done is a product of force and distance. So work done in raising the mass, force will be F. And the distance which is moved, because it move a distance h, so we'll write h here. What about the work done in moving the gas? So work done in pushing the gas, that is again the force multiplied by distance. But what is the force applied by when moving the mass, what is the force applied equals to its weight? So it will be mgh. And what is the force applied by the gas when it is moving the piston? Pressure is force over area. So the force will be pressure times area. So we can say pressure multiplied by area into. So the force to push the gas is, or the piston, that is pressure times the area. And the force to lift the object, that is weight of an object or mass times the gravity. So that is the total work done. We need a ratio between a gravitational potential energy and the work done. So the gravitational potential energy is mgh and the work done by the gas is mgh to move this object. And PA, which is equals to the pressure times area and height. So you can see height is common. Like in a denominator, h is common, so I can take h common. So mgh divided by mg plus PA. And h I took common. H cancel with m, so it will become mg divided by mg plus PA. Why this m cannot be cancelled? Because it is not a common factor. If it was a common in denominator and numerator, then I will cancel that as well. So it is mg divided by mg plus PA. So B will be the right answer. So whenever a gas is doing a work, it is doing a work to expand the gas plus it is doing a work to lift this load which is placed on the platform. That's why the total work done will be the sum of the two. Is it clear? Question 7. Question 8, any doubt? Question 8, any doubt? In question 8, an 8 Newton weight is attached to a lower end of a spring, which is fixed at the upper end. The weight is initially held at rest, so we kept it at rest. It's not moving. The spring is unstretched. At this moment, the spring is not stretched. The weight is then released and it fall to a position Y, and then which is 4 centimeter below X, and then the weight oscillate, move up and down, and it comes to rest at O, which is 2 centimeter below X. So it will stop like what we did. This was an unstretched spring. We add a load of 8 Newton, and that 8 Newton cause the oscillation of the spring until it is stopped at O. How much energy is lost from the system? First thing you have to understand which form of energy this will have at point X. The spring is unstretched, so there is no elastic strain energy right this point, because if you read the question, they mention at point X the spring is unstretched, no elastic strain energy. So which form of energy it will have? If we consider the origin here, the maximum position, like the position it reached at the bottom. So with reference to this position, which form of energy it will have? It will have a gravitational potential energy, which is mgh. And when it is stop here, when it stop at point O, which form of energy it will have? It will have two forms of energies. One is because it is at certain level above the origin, so it will have a gravitational potential energy. And because the spring is being stretched, so spring will have elastic strain energy. So what we will do, we'll find what is the starting energy, like the total initial energy, and we'll find the total final energy, and we just subtract the initial minus the final. We'll know how much energy is lost from the system. So if we need the gravitational potential energy, which is mgh, mg is actually the weight, which is 8 Newton, and the height above. So what is the height above the origin? It's 4 centimeter or 0.04. So 8 multiplied by 0.04, what's the answer? 0.32. So the 0.32 joules of energy it is having at point X. But how much energy it is having at point O? Why we did not include this? Because we want to know how much energy is lost from the system. So once it is stationary, we can just subtract to know how much. That's why we took only initial and final, not in between. This point B, we just took a reference point that is the maximum from the from the position where we reach. That's the maximum displacement it is having, the vertical. So at the final, it will have a gravitational potential energy, which is mgh, plus the elastic strain energy, half force into extension. Mg is a weight, so it's the same 8 Newton weight is there. And what about the height? 0.02, because centimeter, plus half. How much is the force? 8. And what is the height? What is the extension from the unstretched length? 2 centimeters extension. Because 2 centimeter extension, and I took the height here, like height above the origin. That is all because total was 4. So this is also 2 centimeters. So this height is actually this level. And the extension is how much from the release point it is being stretched. So that is also 0.02. So this will be 0.16 plus, when we simplify this, 0.08. So this will be 0.24. So 0.24 joules of energy it is having. So just take the difference of the two energies, like kinetic energy is half mv square and elastic strain energy is force into extension. So 0.02 times 8 divided by 2, that is 0.08. And then it is 0.16. So this is 0.24. So 0.24 joules of energy is the final, and initially is 0.32. The question is how much energy is lost. So we just subtract 0.32 minus 0.24. So how much energy being lost? So be 0.08 joules of energy is lost from the system. Is it clear, this one? . Question 9, any doubt? Question 10, any doubt? Question 10. Question 11, any doubt? Question 11, any doubt? Question 12. In question 12, the work surface in a kitchen is made of a marble. Marble is suitable because why marble is suitable? Because marble is it cannot deform like we use the this surface of the kitchen usually made up of a marble. What is the characteristic of the marble? Its surface is very hard. It does not deform. So C is the right answer. Malleable means we can hammer into shape. Marble is not a malleable material. If you hammer the marble, like you hit the marble, it will just break without deforming, or a no or a very plastic, little plastic deformation. So marble is can break down. So it's not a malleable material. It is a hard surface is there, so it cannot deform easily. That's why. Question 13. Any doubt? This is related to equation of the motion. Question 14. Any doubt? Question 14. Question 15. No doubt. Question 16. Any doubt? That is the last, I guess. Yeah, this is the last question. Question 16. Any doubt in this? Okay. In question 16, a stationary uniform ladder leans against a smooth wall as shown. The ground is rough. Which of the following diagram shows the forces which are acting on the ladder? So, different forces can act on an object and different types of forces can act on an object. First thing, they mention it's a rough. So, what is the tendency of the ladder is to skid, like slide down. So, the ladder will slide down. So, there will be a friction which try to oppose the motion. The friction of the ground to the surface that will try to oppose the motion of the ladder. That is one force. Then the ladder is in contact with the ground as well. So when any object is in contact, there is a normal contact force. So there will be a normal contact force, N will be there. The ladder is also in contact with the wall. So there will be a normal contact force or N will be there. And this ladder will also have its weight and its weight will act downward. So friction is there, which is opposing the motion. The normal contact forces are there. One is from the ground, one is from the wall, and the weight of the ladder that is acting downward. So which one it match with? It matches with option C. So it matches with option C. Like the normal contact force, the friction, the normal contact force, and the weight. Is it clear? So this was a weekly pop quiz.